This is my third video in a series looking at the osci function, which is an oscillator that's used in Affinity Photo's procedural texture filter. So you can do some pretty interesting things with this one. I can make a bunch of different, sort of change the shape quite a bit. And then I can also change the colors here, but you can make pretty complex shapes with this, add a bunch more lines to it with that, and more cells, like zoom out with it with that one. But in this one I want to go through and explain sort of how this filter does what it does and how it works, so that you'll be able to make your own and figure out how to do them. So to get started, I'm going to start with something quite a bit simpler than this, and so I'm just going to go back and delete this. I've started with a 1000 pixel by 1000 pixel image, and so I'm just going to add an equation, and I'll move up my custom inputs, and I'm going to add I guess 3 custom inputs, A, B, and C. And so the first thing I'm going to do is to put in osci. I'm going to call this one osci. I'm calling it osci. And I'm going to put in just sine of x. And when I do that, I notice I get some stripes right away. So I'm going to change these red, green, and blue. I'm going to apply it to all colors. So osci is putting out either a 1 or a 0 depending on this input, sine of x. So if I look back at when I just had x in there, osci of x, I had these tiny little stripes, each one 1 pixel wide. Right? But now when I put in sine of x, then okay, I have nice wide stripes, and at first I was confused by that. The other thing that was sort of confusing to me is I thought maybe I would see, sort of a sine wave on this. Where's the sine wave? And so if you watch the other videos, I talked about how this is sort of like taking contours of a three-dimensional surface, and so it's curving up, but you're taking a contour partway through that, or it's curving down over on this side, and then you're looking at the contour through it. So to get a visual of that, I've created one in Blender. So this is the surface that I've created when I put in just sine of x. It's creating a surface like this, and then this line is the plane. And anytime it's positive, it's creating a white area. Anytime it's negative, it's creating a dark area. So if I look at this from the z-axis straight down on it, I can see this would be white, this would be black, white, black, white, black, like that. So I can sort of imagine what this is like. Now, this one is set to, I'm going to just reduce this one. When it's 1, if I add another plane above and below this, it doesn't get a chance to change, okay? But if I increase the amount, scale up the z value, now I've added another transitions, because the osci oscillator changes every time you go pass a whole number boundary. From 0 to 1, it's going to be white. And then when I cross over the boundary from 1 to 2, it's going to be black. Same thing down here. From 0 to -1, it's going to be black. And then when I cross over this boundary, it's going to be white. If I look at what's happening with the sine function, it begins at 0. It goes up until it gets to be at 90 degrees. It reaches a maximum of 1. And then it drops off until at 180 degrees, it reaches 0, and then it continues to go down until at 270 degrees it reaches a minimum of at -1, and then it goes back up again till at 360 degrees it's back to 0 again. So that's what we're seeing here. After 180 pixels it switches from white to black, and then after another 180 pixels it's going to switch to white again and continue that all the way across. So if I look at my image, I have 360 here, another 360 is 720, and then I have 180, which is 900, and so then I've only got 100 pixels left for the last stripe, so that's why I only get a partial stripe there. Now I can correct for this, and I'm going to change it so that one cycle occupies the whole width of this, and then scale it by this factor A. So I'm going to set A to 1, and I'm going to put in and multiply x by times A divided by W, but then I have to multiply by 360 degrees to get this to come out just the right size. So now I have a full cycle across that. And as I increase A by 1, I'll add another cycle of the sine wave. Now, it doesn't look like a sine wave, but I'm going to show how to do that in just a minute. Next thing I'm going to do is put in a B, put this other multiplier in front of the sine. So I'm going to put my B times this over here and increase that. And now as B increases, what I'm really doing is increasing the Z value, and so it's going to overlap more. I'm going to get more whole number transitions, so I'm just going to bring it down to 2. At 2, this range is between 0 and 1, and then this black area here is between 1 and 2. Then I go back to 1 to 0, and then I go from 0 to -1, and this one is -1 to -2, okay, in the middle here. So that's how it's changing, and so that's why I get more stripes as I change this the size of the number that's going into osci. Okay, it's creating more contour lines. Right, so as I increase this, I'll just get more and more lines. Okay, but I want to see my sine wave, and I can do that. So I'm going to go back to Blender, and I have one set up where I set up a pattern at an angle. So I put a sine on a slope like this. And so when I do that, I can see that the planes are going to cut it, but if I look at it straight at Z, instead of just straight lines, now I can see this oscillation. And each, where Z crosses this is like a whole number transition. So the 3 different planes that I have set up here create a whole number transition. As I turn these off, you can see where the next one goes. So like that. So it'll have a series of overlapping waves when I do that. So let's go back and try that and see how it works. So I can do that by adding a outside of the parentheses for the sine. If I add y times a, I'll actually put in, I've used a and b, I'll use c for this one, divide by w, like that. And then if I increase this, okay, now I can see my sines. And this, as I bring c up, I'm making it at, I'm putting y is intercepting, is changing the slope of my ridges of my sine curve. So I get more and more transitions, more and more whole number transitions through this as I bring that up. So now I can change, use A to change the frequency, make it more wavy, and then this one can give me more numbers like that. Okay, so the other thing I can do that also is pretty interesting is what if I do a, instead of just a y here, I could put in a, put in c times sine of y times a divided by w times 360. Okay, like that. Let's see if that works. Okay, so I'm going to bring this down quite a bit to 1. Okay, now I can bring this up like that. So what's going on with this one? So I have sine of x. It's basically sine of x plus sine of y. So I created a surface like that using Blender. Blender can create mathematical surfaces, and I'll show you what that one looks like. I'm going to turn off the -1 plane and the +1 plane, so I just have my 0 plane on there. And then I'm going to hide the sloped one. This is the sine of x plus sine of y. So that looks sort of like, I don't know, an egg carton or something. So it's all these rounded bumps on here, okay? And you can scale that. I can scale that with z. I can make it 3. Let's see, I have to select that. So I can scale that. I could make this 2, and then it gets bigger. So I can scale that up. And then where it crosses these planes, that's how it's going to, change the numeric value of this. So I'm going to put this back down to 1, and let's turn on this plane. So if I look at this from looking straight down on it, oops, if I look at this straight down on it, I'll see a series of circles, okay? But then where it crosses the next plane, it's going to generate sort of this checkerboard pattern. And that's exactly what I see. So one of them, this is where it's a white checker or square on the checkerboard. This is where it's a black square on the checkerboard. So that's basically how it's working in this pattern. So I can create a pattern like that, or as I increase the magnitude of this, B, or the amplitude of B and C, like that, I get more and more rings on here. Okay. All right, I'm going to take a look at the equation I used for this filter now. So the first thing I'm doing is to create 2 color vectors, R1, G1, B1, a 3-element vector, and down here VC2, another 3-element vector consisting of R2, G2, and B2. And I have sliders for those over here. Then I'm going to create a variable for the SX. So instead of multiplying each one by all of this, I put that all into this variable, so it'd be easier to write my equation down here. So I created Sx and Sy, consisting of, this one is A times Rx divided by W times 360. This is A times Ry divided by W times 360. Then I have my osci oscillator out here. I multiply it by the color, so that's where I get the color from. And then inside I have sine of Sx. Now instead of just adding these two together, I wanted to have it be all positive numbers. So sine goes from always goes up to +1 and down to -1. And so I'm scaling that. I'm adding 1 to that, so that'll make it go from 0 up to +2, but then I divide by 2. So I bring it back down so it's in the range from 0 to 1 again. Do the same thing over here with this one. And then I'm scaling this by 2 factors. One of them increases the number of contours, that's the B basically, but then the C is a slider that goes from minus 1 to 1. And then I have a different slider controlling D. So that way I can sort of scale them all at once, but then I have a separate control for each of the two oscillators in here. Down here for my second color, I take 1 minus osci, all of that. And that creates a color on the opposite side. So here's my basic pattern. So this is the one I chose for default. But then I have this one, blue eyes. This one has pink and purple dots. I'll put the equation in the description for the video, but if you pause the video, you should be able to copy these inputs and put in your, adjust them if you wanted to match one of these patterns. There's another one, blue waves, red, green. So these are, like some of the other patterns, these are pretty cool to, one of the things I can do if I can add these as a text, as a pattern, to pattern some text. So I'm just going to bring this up to a pretty large number. It seems to work better if I do that. If I apply it, I can bring in a text. Now I make this white and then drag it onto this, and then I'll just add a background layer here, maybe like that, and then back on this one add a little bit of an effect and maybe a little bit of shadow. Okay, something like that. Yeah, so that's all I wanted to do in this one, and so let me know if you have any comments or questions. And thanks for watching.